Hi, this is Patrick Mohammed, and this is my lab for oscillations. The purpose of this lab is to compare the predicted motion in glow script with the observed motion that we find in tracker of a mass attached to spring, and then graph the energy changes that occur in the system for predicted motion. And we are going to analyze potential energy, gravitational potential energy, kinetic energy, spring potential energy, and the total energy. And the results is that the predicted motion and observed motion are similar but differ in the y-axis to a greater degree than they do in the x, and that the change in total energy is zero. Physics concepts. So the first is Newton's second law. We have velocity update and the kinematic formula. That's just F net equals the change in momentum over change in time. Final velocity is equivalent to the initial velocity plus force divided by mass times time, and the kinematic formula is just final position is equivalent to the initial position plus the average velocity times time. We have the energy principle, which is just the energy of the system is equal to the work done from its surroundings plus the change in temperature Q. Kinetic energy is just 1/2 mv squared. Spring potential is 1/2 ks squared, with k being the spring constant and s being that length change. And then gravitational potential energy is just mass times gravity times the height change, or you could use mgy. We've got the free body diagram. It's rudimentary, but it is in static equilibrium because the force of the spring is equal to the force of gravity at the final position, and our system is obviously Earth due to the force of gravity, spring, the spring force, and then the mass. And there's no surroundings. And the energy of the system is just the kinetic energy plus the gravitational plus the spring potential, which is really just spring potential minus gravity. Photos from my tracker. I just recorded 2 frames, one of it going down and one of it returning, so we can see this oscillating motion. In the sinusoidal graphs, we find that my FPS was about 0.8, or 0.08, I should say. My initial position was 0.1 meters, negative 0.64 meters. Obviously, no initial velocity, and the time that elapsed was 6.5 seconds, with the mass being about 4 kilograms. Or being 4 kilograms, I'm sorry. Alright, the sinusoidal graph. This is just the images of the code. We see that the vector has been changed, the mass has changed. For my computational model, I just imported the ks I found in the initial length. I also found, we know that this k is equal to mass divided by oscillation over 2 pi squared. And oscillation is 2 pi with the root of mass divided by k. Computational model. This is more photos of my code where I changed the formulas for velocity and position accordingly and incorporate L hat for the spring force. And we find that using what we know, what we can find, we can boil the energy of the system down to 1/2 m times vf squared minus vi squared plus mgh plus 1/2 k sf squared minus si squared. And I changed my rate to 10, and it is for less than a count of 0.08 for my frames. The results, we see that the overlap is pretty close, but we have differences in those y's just because, probably due to tracker not catching that consistent center of mass. And then we see that our energies are going to be inverses of each other, or negatives. So just to discuss the change in energy versus time graph, the change in gravitational potential energy and change in spring potential energy are opposite in sign and oscillate. That's just for our E net 0. The change in kinetic energy also oscillates, but it is of less magnitude. And then our position versus time graph, the Y is just less accurate than the X. Again, due to that COM. And this error is probably in drag and air resistance forces, especially for the Y component with MGH, and then inconsistent center of mass. For the questions, is the energy principle satisfied? It is. We see this because the graphs are equal but opposite, and the energies are net 0, so that we'd find change in energy to also be net 0, and we just know that spring force plus the kinetic energy of the system is equivalent to MGH. And then the last question, estimation of oscillation periods, that's indicated in green. I guessed that my period was about 1.7 seconds for an average for the X, and then an average of 1.5 for the Y. This difference does affect the spring constant, the force of the spring, and then the spring potential energy, obviously, and it's probably caused by drag forces and inconsistent center of masses. Thank you.